Welcome to Miss Lowell's class.
Thank you, Kaylee. Can you draw sigma for everyone? Very good. And what does it mean?
Let me draw it.
You're my star student. All right, guys, we are on lesson 77 called Geometric Series. Okay, so there are arithmetic series and geometric series, and we really just focus on the geometric series, which if we think about the last lesson, we have this Greek letter sigma, right? That means to add up all the terms in that sequence, and the sequence is given by the expression here. So we're going to look at geometric sequence that we're going to add up. So we call that a geometric series. Now, there's another formula that we can use when we have a geometric series and we need to add up a bunch of numbers that fall into a geometric sequence. So let's look at the do now first, which I just want to point out, my nails after 5 weeks are almost off, except for the pinky, so I'll be working on that later today. Okay, so evaluate. So we have our summation of 3 times 2 to the n as n goes from 1 to 3. Okay, so we know, and I showed you, that you can just plug this into the calculator. But let's just refresh our memories about what this means, okay? Because we don't want to just, blindly plug things into the calculator without understanding what it means. So this means that we're going to plug in n to be 1, n2, n3. And up into this top number and every integer in between. So we're going to have 3 times 2 to the 1. So that would be 2 to the 1 is 2 times 3 is 6. Then 3 times 2 to the second. So 2 to the second is 4. 4 times 3 is 12. And 3 times 2 to the third. 2 to the third is 8. 8 times 3 is 24. Okay, and then we're going to add up these numbers because that's what sigma means, to add up. So I have 6 plus 12 plus 24, so that's going to give me 42. Okay, and again, I could plug this into the calculator like I showed you and get the same answer. So now look over here. So I have n equals 1 to 25. So now if I were to do this by hand, which, by the way, the older calculators didn't have this option. So, we didn't always have the luxury of just plugging this whole thing in the calculator and getting a single answer. So we would have to plug in 1 and every integer up to 25. So we would have 25 terms in this series that we're adding together, which is a little crazy to do. So that's why we have this other formula, because if it's a pattern, if it's a geometric pattern, then we can predict what all of the terms are going to be. And then this formula here can actually calculate what all of the terms are going to add up to without having to know what every single term is. So to find the sum of a certain number of terms of a geometric sequence, we can use this formula. Okay, so this formula is saying the sum of n terms. So the sum of however many terms I need to add up. So if I was doing this one, it's 25 terms because it's going from 1 to 25. You just need to know the first term, not the spot number, but what is the first answer you get when you plug n as 1 in, minus a sub 1, so that same number, multiplied by the r to the nth power. So what is the r in this particular geometric series? And I see that this is the initial value. This is the b, that's the r. like b as in like the exponential growth, right? But it's the r in geometric series. It's what you're multiplying by. Raised to the nth power, how many terms are you actually adding together? And divide that by 1 minus the r. So if I know those things, then I know I can figure out this sum without actually having to find all 25 terms and then adding them up. So why don't we try to use this formula here for this, okay? So a sub 1 is going to be the first term. So the first term I get from plugging in n is 1. So I have 3 times 2 to the 1, which is 6. So the first term is 6. Then the r is what I'm multiplying by to get to the next term. And actually, it's the same formula, it's the same, equation as this problem, and I can just tell, even if I wasn't sure from the actual layout of the expression, I could tell from the terms it's 6, 12, 24, right? So it's multiplying by 2. So that's what the r is 2. And it goes from 1 to 25. So that means that I'm going to plug in 25 numbers for n, and I'm going to get 25 terms. So the n is 25. Just keep in mind that if this bottom number were like 0 or 2 or something other than 1, then it's not going to be 25 numbers. It's going to be however many numbers from the bottom to the top. Okay, so if this was 0, that'd actually be 26 terms. If this was 2, it would actually be 24 terms, right? So you have to just be careful about where it starts and where it ends. All right, so now I can, instead of finding these 25 numbers, I can now take this information and plug it into this formula. So S sub 25, so the sum of 25 numbers, let me just move this over, equals the first term, 6, minus the first term times the r, which is 2, to the nth power, so that's 25, all over 1 minus r, so 1 minus 2. Okay, so now if I plug that into the calculator, which I'm going to pull up on my screen here, so I will show you my calculator. Okay, so let's plug in, I'm going to use the fancy fraction because I want to make sure that I type it in correctly. So 6 minus 6 times 2 raised to the 25th power divided by 1 minus 2. If I did not use the fancy fraction, then I would have to make sure to put parentheses around the 1 minus 2 so that it subtracts that first and divides by what 1 minus 2 is. Or I could just figure out 1 minus 2 is negative 1 and just write divide by negative 1. So I'm just going to type it exactly like that, and I get this really big number, which makes sense. It's an exponential growth, really, that I'm adding 25 terms of. And then just to check, I could go to math and go up to summation and plug in the original do now number 2 question. Oops, I hit the wrong thing. Let's do x equals 1 up to 25. And then it's 3 times 2 to the x. Okay, so just to note here, do you see how I have like the 3 times 2 to the x in the big parentheses? You want to make sure it's written like that, because if it's not, it's going to do the summation of what's ever in the parentheses. Like if you put this x on the outside here of the parentheses, it's going to just do the sum of what's inside and then raise that answer to the x. You want it to look like this. Okay, and you see you get the same exact answer. So there's actually 2 ways to represent a geometric series. You can use the geometric series formula, which is this, or you can use the summation to represent it. But then again, if you had to do that by hand, that would take a really long time. So that's why we have this formula too, because it's a little shorter and we don't have to find every single term. this part got cut off before. So find the sum of the first 8 terms of the sequence. So you could just find the pattern and find the 8 terms and then just add them up together. And it doesn't say here you have to use this formula, so you could do that. That's not the best idea when this is a big number. You know, add up the first 100 terms of a sequence. That would take way longer. So if it doesn't say how to add it up, you have a couple options. All right, we're going to practice using this formula. So for this formula, I need 3 things. I need A1, I need R, and I need N. So the first term is -5. R is what we're multiplying by, the common ratio. So it's going backwards, it's dividing and what you get, or going forward and multiplying. So I see that it's multiplying by -3. And N is how many terms you're adding together, which is 8. Okay, so then we plug it into the formula. So -5 minus -5 times R is -3 raised to the nth power, which is 8, divided by 1 minus -3. Now be careful, make sure only the R is to the nth power. So I have parentheses around the -3. So we're going to type this into the calculator carefully, which I'm going to show you. And then we should get 8,200. Okay, so I'm going to type in example 1. So again, alpha y equals for my fraction, my fancy fraction. And then, of course, make sure you're typing in the negative symbol, -5, and then subtract -5. So you could write plus, or you can just type it in exactly as you see it. Parentheses, make sure that R is in parentheses because it's only R that's to the 8th power and not both the -5 times -3. Okay. And then divide by 1 minus -3, which we know is really 4. So you could do that instead. And I get 8,200. Okay. So that's the sum of the first 8 terms of that sequence. And again, like I said before, you could just keep multiplying by -3, get all 8 terms, add them up, and you'll get the same thing. All right, but when you have a lot of terms you have to add up, that's probably not the best option. Okay, so we got our answer of 8,200. All right, then it says find the example 2. Find the sum of 5 terms of the geometric series whose first term is 2 and whose 5th term is 162. Okay, so again, it's sum of 5 terms. So that's not a lot of numbers. So if I just want to sit here and figure out what all 5 terms are and then add them up, I could. It doesn't say I have to use this geometric series formula. Sometimes it's going to say that. So I'm going to use this formula to practice using it. So the first term is 2. So A sub 1 is 2. Got it. And then I need R. R is what I'm multiplying by to get to the next term, but they didn't give me that. They gave me the first term and the 5th term. So I'm going to have to figure out what R is regardless, even if I'm not going to use this formula and I'm going to just, find the 5 numbers and add them up, I still have to figure out R. And then N is how many terms I'm adding together, so that's 5. All right, so we did this kind of question a few lessons ago. I forget the lesson number, maybe 75, I think, where they gave you one of the terms and they gave you another term, not a consecutive term, and you had to go backwards and kind of figure it out. So this is where I like to draw it. So the first term is 2, and then the second, third, fourth, 5th term is 162. And this is, you could kind of just do guess and check if you're good at that. Sometimes it's fractions that you're multiplying by, so that might be harder to guess and check, but sometimes it's a whole number and you can kind of just tell. So for calculating it, besides guessing and checking, you're really going backwards, right? And it's geometric, so that means we're going backwards and we're dividing. So 162 divided by 2, right? So that is equal to how many R's did you multiply to get there? So not how many spots, there's 3 blank spots, right? But how many times did you multiply by R to get from here to here? So multiply 2 by R to get to this spot. Multiply this number by R to get to this spot. Multiply this number by R to get to this spot. And then multiply that number by R to get to this spot. So you actually multiplied by R, that's a multiplication. You actually multiply by R 4 times, even though there's 3 spots, right? So R times R times R times R is R to the 4th. So when you go backwards and divide, this amount is equal to R to the 4th. And now you could just figure out what that is. So 162 divided by 2, so that's 81, equals R to the 4th. And then you solve for R. So remember, we've done this before. You either 4th root it or raise it to the 1/4. Those are the same thing, right? We learned that in the last unit. So raise it to the 1/4 or do the 4th root. That cancels it out. And 81 to the 1/4, I could just type that in my calculator. And I get 3, so R is 3. So you could have guessed and checked that too. So now that R is 3, now I multiply and I can find all the terms. Or I could just come here, I don't have to find all the terms because I can now use my series formula that I have up here. So that's what I'm gonna use. So the sum of 5 terms, where the first term is 2, minus the first term 2 times the R is 3, raised to how many terms? 5 terms, over 1 minus R, which is 1 minus 3. Okay, so again, I'm going to type that into my calculator. So that is going to be 2 minus 2 times 3 raised to the 5th. And then divided by 1 minus 3, which is -2. And I get 242. Okay. Now, if I was over here, I could have multiplied by 3, multiplied by 3, multiplied by 3, and then multiply by 3. And then I get the same thing when I take all these numbers and add it up. I should still get 242. Is that cut off? I'm sorry. I didn't realize. Okay, sorry, cut off. So just in case you didn't miss that part. So 162 divided by 2 equals R to the 4th. So we raise both sides to the 1/4. So R is equal to 3, and then we plugs it into our formula. So a sub 1 minus a sub 1 times 3 to the 5th, all over 1 minus 3, and I typed that in and got 242. All right, I'm going to leave example 3 for you to try on your own because it's really kind of the same thing. Just remember, when the signs are changing like that, that means the R is negative. Okay. So example 4 says, let me make sure you can see this. Kristen wants to increase her running endurance. According to experts, a gradual mileage increase of 10% per week can reduce the risk of an injury. If Kristen runs 8 miles in week 1, which expression can help her find the total number of miles she will have run over the course of her 6-week training program? All right. Okay, so let's take a look at the choices. So now we can't just eliminate any of the choices because they're written a certain way initially. Like, just because this has the sigma notation and these don't, doesn't mean that they're any of them are automatically wrong, because you can write a geometric series using the formula that we just saw on the other page. So using this series formula, or we could write it with sigma notation. So both ways of writing it are right. We just have to make sure that specifically the numbers in there are put in correctly. All right, so gradual mileage increase of 10% per week. So that means that we are multiplying by a number that makes the next number 10% more than the previous number. So that means that we have to use that 1 plus R, right? So if we're increasing something by 10%, 10% is 0.1, but the R, which we'll talk about the letter R in a second, the R as far as a geometric series is the common ratio. What is the common, I guess, when you're dividing, what is that number every time, or what is the number you're multiplying by, right? So it can't just be 0.1, because let's say she starts at 8 miles, right? If we just multiply 8 times 0.1, we're going to get 0.8. And that is not how much she's running the next week. That's how much she's increasing by. So the R, meaning the common ratio, has to be 1.1. So now let's just talk about the letter R for a second, because you might be confused, like, well, I thought R was just like the rate as a decimal. It is when we're talking about exponential growth and decay. When we're talking about geometric series here, R is the common ratio, which I know is confusing, but you need to think about the context of the questions too. Okay, so will that number get you to the next number is the question. So 0.1 won't get you to the next number. Multiplying by 1.1 will. All right, so we're looking for a common ratio of 1.1. Then the first mile, she's running 8 miles. So A sub 1 is 8. And then which expression can help her find the total number of miles over her 6-week training course? So she's running for 6 weeks, right? So let's kind of go through each choice and see which one is going to be correct. So if we plug in here, if we look at these two sigmas, let's compare them, right? So n goes from 1 to 6. N goes from 1 to 6. So that's right, because it's week 1 to week 6. And then we have our formula. Now this formula is supposed to be your explicit formula that is going to get you to the next term. So if you plugged in 1 here, you should get what she is getting in week 1. So I have 8, which is the first week, times 1.1 to the n minus 1, whereas this one is 1.1 to the n. So what's the difference? Well, if I plug in 1 here, week 1, then that means that this is going to be 1 minus 1 is 0, and anything to the 0 power is 1. So week 1 is going to be 8 miles, which is true. But if I plug in 1 here, it's 1.1 to the first power, and then multiply that by 8. So I'm going to get 8.8 for the first week, which is not true. So that's why this is wrong. Okay, so this is looking good. Pretty sure that's going to be it. But let's check the other ones. So on these two, I recognize the structure, and the structure of it is this formula, right? So it's supposed to be A1, which is 8, that's right, minus A1, which is 8, that's right, times R, which is 1.1. This one is not, this one's out. Raised to the 6th, because it's how many weeks, that's right, divided by, the bottom's supposed to be 1 minus R. Well, 1 minus R is 1 minus 1.1, which is not 0.9, it's negative 0.1. So this one's out too. So it has to be choice 1. Okay. Another thing you could do is you could actually just find all 6 weeks, find the 8 and the 8.8, multiply by 1.1, and find all 6 weeks, add them up, and then plug these in and see which one matches. Okay, so you could always do that. All right, so now example 5, this is one where they're forcing you to use the series formula. So it says Rowan is running a race, training to run in a race. He runs 15 miles the first week, and each week following he runs 3% more than the week before. Using a geometric series formula. So now they're forcing you to use the formula. Find the total number of miles Rowan runs over the first 10 weeks of training, rounded to the nearest thousandth. Okay, so we have to use the geometric series formula. We can't just write out the weeks and then figure it out ourselves. Okay, so he runs 15 miles in the first week. So A sub 1 is 15. And each week he runs 3% more. Okay, so that means we're multiplying by a number that's going to increase the previous number by 3%. So that means that 3% is 0.03, right? So that means I need 1.03 to be the R. That's what I'm multiplying by. Using a geometric series formula, find the total number of miles he runs over the first 10 weeks. So that's your N. N is 10. So then I'm going to use this formula back here on the front, and I'm going to plug in. right? So a sub 1 minus a sub 1 times r to the n over 1 minus r. Okay, so the sum of 10 weeks is 15 minus 15 times 1.03 to the 10th power over 1 minus 10. Nope, sorry. 1 minus 1.03. 1 minus r, it's supposed to be. All right, so now I'm just going to plug it into my calculator. So let's see. So I have 15. Let's do fancy fraction. Okay, and I typed it in the calculator. I got a decimal. I go back and I read to the nearest thousandth. So that's going to be 3 spots after the decimal. So 171.958 miles over the 10 weeks. Okay. All right, so go ahead and see if you can try back to example 3 and the homework questions on your own and check your answers after you have given it a shot. Good luck.